Conservation of energy for moving charges. So when a charge moves from one position to another in an electric field, the change in electrical potential energy must be accompanied by a change in other forms of energy so the total energy remains constant. So delta E equals 0, delta kinetic energy plus delta potential energy has to equal 0. It is not a new concept. It is the same principle that we've been talking about in Intro 1 and in other places. It is exactly the same as the energy conservation rules followed everywhere else. It is now just applied to electrical potential energy. So electron gun in a cathode ray tube. An electron gun, electrons are accelerated from a cathode towards the anode, which is at a higher potential than the cathode. If the potential difference between the cathode and anode is 12 kilowatts, at what speed do the electrons move as they reach the anode? Assume that the initial kinetic energy of electrons as they leave the cathode is negligible. So this is what a cathode ray tube looks like. So we're going to solve this problem by two methods. Method 1 is going to involve conservation. Method 1, delta E equals 0. So what does it say? We know that it is potential difference between the cathode and anode is going to be 12 volts. So V equals 12 kilovolts. And we want to find what speed do the electrons move as they reach anode. Assume that the kinetic delta E initial is equals to 0. So first method we are going to use is conservation of energy. What does this mean? This means delta kinetic energy plus delta potential energy has to equal 0. This implies Ki plus Pi will equals Kf plus Pf. Kinetic plus potential, right? We know that kinetic energy initial is 0. And we know that the final potential energy is 0. We can just assume that for the anode, the electron is going to have 0 potential energy because it's going to come to rest at the anode. Then potential energy, which is U, is going to be given by minus E delta V equals 1/2 mVf squared. Why minus sign? Because we're talking about electrons. What are we looking for? We are looking for Vf. So I can rearrange this equation as 2mq delta V. Whoops, m comes down. V squared, right? So now all I have to do is plug in the numbers, calculate, and solve. I will get Vf equals to 6.5 times 10 to the 7 meters per second. Remember, Q, because it is minus 1.6 times 10 to the minus 19 coulombs. Now, method 2, I am going to use Newton's second law. What do I know? I know V equals ED from last movie. We talked about this. I also know sigma F equals MA equals FE in this case, which is the only force that's acting on this system, right? This implies MA equals QE. Yes? This implies MA equals Q V over D, right, from here. What next? I need to find A equals QV over MD. This is what I know. But I need to find VF. How do I find VF? So I can find VF squared minus V naught squared equals 2A delta X, the distance that it goes. The third equation of motion, I know V initial is 0. I can plug this value in here. So VF squared will equals 2A QV divided by MD. I have all of those values, and that's the same exact value as I had before. Oops, I forgot to take out the A. But this is exactly the same thing as here. And there we go.